Hello Internet, in this video we are going to be working on creating a dice roller. I know that sounds simple, but what I'm trying to create here is something so you can roll a dice, any type of dice, be that a coin or a d20 or whatever, and actually physically simulate it and then tell what got rolled programmatically. So you don't have to do anything special to calculate that. So effectively what this video is dot products in applied form. That's how we're going to be solving it. There's going to be a little bit of matrix math as well, I think. I don't really know. I'm thinking we can do it with matrices and with some dot products. So that's sort of where I'm going. I already have this sort of thing created. So if you're familiar with like dice rollers, that's what this giant tower is. I just built it in Pro Builder in like 2 minutes. And then we just have a cube. And each side, we're not going to use numbers for our dice, sort of to illustrate that you can use anything you want. We're going to use an enum of these 6 different colors. So we've got black and white on one side, green and red on the other, and then purple and yellow on the final 2 sides. And so that's our basic dice. So what happens is I do have a little script here that kind of rotates it randomly. And then it will fall down and you'll get that. So what we need to do is be able to say at the end that we got green. And that's what we're going to be working on. So I'm going to start off by just creating a dice. I guess that makes sense. So what we need is a public vector 3. So I'm going to create an array that is going to have vectors, one-dimensional or normalized vectors based off of the dice that kind of point in the direction of wherever you need to go. And so in this case, it's just going to be along each axis. If you do a more complex dice, it's going to change, obviously. But what we can do with this is we can take those. Those will be in object space. Then we can use our transform and actually transform the object space vectors into world space, and then calculate a dot product between each of those vectors and the up vector of our world. So that's just vector dot up, and then whichever one is the greatest, that's the one that's going to be up. We could actually do like a check to see if it's like greater than or almost 1. Which would mean it's actually facing up, but this way, even if there's like a cocked dice, you'll still get an answer. So we have these vectors, and these are going to be our result values. And as I'm doing this, I'm thinking we may run into some issues with this. Initially, I was thinking the easier way to do this, it would be to create like some child elements and then have them actually oriented in each direction. The problem with that is then you need a new element for every single side of your dice, which seems like a waste. So we're not going to do that. That's the wrong project. So we're going to do this instead. So I'm going to start off by writing some gizmos on draw gizmos. And the reason we're doing that is just because it's going to be way easier for me to actually tell what is going on when I can actually see these vectors. So we're going to do just a gizmos.color, and we're going to set it equal to like color.red, I guess. My IntelliSense is totally broke, so I may need to restart this, but we can continue anyway. For each value vector in our result values, that's a poor name, I'm realizing. What we need to do is take this dot transform, and I'm going to get IntelliSense back for this. I don't know why it keeps going away. It's sort of a weird thing. I don't know if it's a Visual Studio or a Unity thing. It seems to be related to recreating the solution every time we change something. I don't know who needs to fix their stuff, but I don't know how to fix it. So I just restart. Anywho, once this decides to respond again, we can, so there are two matrices attached to these transforms. One of them, matrix, is the local to world space. So local is object space, which is relative to the object you're actually working with. The other one is world to local, which will take world space coordinates and translate them into space related to whatever object. So you could use that if you always want something to end up on top of whatever object, even if you rotate it, you can do that. We're going to do the other one. So we're going to do a local to world matrix. And I believe, this might be bad. So I said we were going to do matrix multiplication, but I didn't, or matrix math, but I didn't actually study how to do this, which might come back and bite us. So world space value vector. That's a mouthful, but should work. How do we multiply you? Don't need any of that. So I think the issue we're running into, these value vectors are, or these matrices are 4 by 4. We have a 3-dimensional vector. We need to get it into 4 by 4 space so we can multiply this, I think. Unless, no, multiply vector. Value vector. There we go. So what this actually does is it does 3 things. It rotates it, and since we're assuming that this is in world space, transforms a direction. Okay, so this should work. I could be very wrong. We're going to find out what our vectors say. And so that's what this is going to show us. So what I'm going to do is let's draw a line from this transform.position to this transform.position plus our world space vector. So theoretically, assuming the translation works, so these are going to be like 1, 0, 0, which would be along the positive x-axis. Theoretically, that would be rotated into object space and it would just be fine. I'm kind of questioning if that's going to work or not, so we're gonna find out the fun way. Mostly, I'm gonna drop this on here. We're doing Gizmos, so we should see something. Or not. I was expecting like a line going way off into somewhere, but it's not, which is weird. Oh wait, hold on. It might be working. I may have done it along our object. So ProBuilder initializes everything in this corner, and I didn't bother to fix it because it doesn't really matter. So let's make this 6. So 1, -1, 1, and -1. So it is working. So what we're getting here is we are getting our 6 vectors. 3 of them are obscured by our object. If I hide that mesh, you can see them a little bit better. So we have all 6 cardinal axes, or all 6 directional axes covered this way. And so as I rotate this, you'll see these vectors are actually staying related to the rest of the object. So that box would be sort of the outline of where the actual cube would be. But as we rotate these, they stay in relation to it because they're using that translation matrix. So that's good. It actually worked and we didn't have to do anything crazy. I'm really happy with that. Awesome. So now that we have that, we just need to do the dot product of these, which is actually not that hard. So really the easiest way is just to have a public int selected vector, And then, if we're going to just iterate over them, let's do it this way. So int I from 0 to I less than the result values dot length. We want to increment I. And then we're going to have some sort of value vector, which is going to be equal to our result values of I. So this is doing the same thing as that for each, but now we have an index. And so what we do here is I'm going to actually cache this. How am I going to do that? Float best dot. So we're going to set the original best dot product to -1, which is the best result we've gotten so far. So what this is doing is effectively -1 will be the exact opposite direction, assuming they're normalized vectors. If they're not, then our math is totally going to be wrong, but that's fine. We don't care, I guess. If it's negative, it means it's in the opposite direction. So it doesn't really know whatever value it is. If it's negative, it means it's down. The two vectors we're calculating are in the opposite directions. So if we're comparing one or like straight up and down, that would be negative. It'd be negative equal to the length of the two vectors. So if they're both normalized, that would be -1. If they're both going in the same direction, you'd get 1. If they're perpendicular to one another, so like one's going along the x-axis and one's along the y-axis, you'll get 0. So with this, we're saying the default value is negative. And so what we can do now is just calculate. So assuming at least one thing comes up positive, that will get overwritten. If it doesn't, then we're doing something really weird. So I don't really care about that. So we're going to keep our world space calculation. We're going to need that. And I don't think you can save yourself that work. I think that's kind of required. You could only do this calculation like when the dice has stopped rolling, if you only care about it at that one point. We're going to do it every frame because, frankly, it's easier. And this way we can actually keep a constant track of which one's up, which could be interesting. So let's see here. Value vector, we want to see your dot product. So float dot equal to the vector 3 dot dot. And it shouldn't matter which order we give them in. And we're just comparing it to the up vector. So straight up in our world. If you're doing like some weird like 6 degree of freedom game or something, you may not be able to use this vector 3 dot up. You'll have to use whatever the table direction is, whatever up is in your world. But in this case, we're going to generalize it down to just up. I guess that makes the most sense. So now what we want to do is if this dot is greater than the best one we've gotten so far, we need to do two things. First, we need to set the best dot equal to our new result. And then we have to set the selected vector equal to the index of the one we just selected. So I should be able to drop this now. And you'll see it's kind of... Where did it go? Oh, I disabled the renderer. That's going to make it hard, isn't it? So we have these values. What I'm going to do next is actually assign these to an enum. Like I said, this can be anything you want. There's nothing restricting you to like integers or enum values or whatever. Any object you want to assign to this should be fine. So I'm just going to create a public enum called our side results, which is another poor name, but that's fine. And the order of these I'm not too concerned about. So yellow and purple. And so that's all 6 of our possible results. So what I want to do is create a public, what did we call it? Side results, which is going to be our, selected result, like so. So we've got our result values. So we're going to call these actually vector values. And our vector points. So we're going to have to redo those, unfortunately. But our vector values are actually going to represent the values that we can get for each index. So if you look at the selected vector, the selected result is whatever vector value is at that index. So, I'm saying that a lot. Let's see. Selected result, I don't care about you yet. Vector points, I need to change you. There we go. So now that we've got all of that, let's swap in our selected result equal to our vector values of our selected vector. And so that's going to set our result equal to whatever's at this index, just so you can easily select that. We could just use a property, that'd probably be easier, but then it doesn't show up in the inspector, and that's sort of why we're doing this. I'm just doing it strictly because I want to see what the results are. Normally, I'd probably actually split these up. So you'll see what side, what index is up, and then you'll have something else to kind of determine what that means. But for this, we're just kind of demoing how this whole idea works, so it doesn't particularly matter. We need 6 of each side. Let's see here. That one is going in the purple direction. So I have to kind of pay attention to this because these vectors are hard to see. Let's see, -1, it's going to be yellow. Suppose I could have guessed that one. 1 is straight up, which I believe is black. So black, which means the opposite is white. And then this one is green, with the opposite being red. So now we have all of those selected, which means I should be able to start this, and based off of what we get black. So black is up here. If I just rotate this manually, does this work? We get red, and you can see we do get red. Sorry, I probably totally obscured all of that, didn't I? That's unfortunate. Woo! That's not gonna work. Okay. Oops. Let's see. Sorry, I'm trying to make it so you guys can actually see. Just because of the way I have my recording set, I can't actually move my camera in post, just because it's easier this way, which I guess in this case it isn't, but normally it's easier. So anyway, we have red up here, and so now that we have red as the result, I should be able to grab this again. Let's say we want purple. You'll see it switches to purple. I can do it again, get green again, and get yellow. Whoa. Go back to black, I guess. Trying to get white just to show that they all work. There we go, white. So in this way, we can kind of select anything. You can do anything, any shape you want. If we wanted to do a coin, there's nothing stopping us from doing a coin. If we wanted to do like a 20-sided die, that's totally possible as well. There's nothing stopping you there. You just need to set everything up. And we could probably abstract this a little bit. Our vector values here, it'd be kind of nice if they were connected to the vector points at the same time. Otherwise, this gets a little disconnected, especially as this grows. It gets very hard to tell what's connected to what. So there's definitely room for improvement here, but I think this kind of highlights sort of the idea. There's not really too much here. It's just a simple matrix multiplication and then a dot product, a bunch of dot products. So yeah, I don't know what else to do. So yeah, that's it for this video. If there's anything you guys want to see or anything you think I should improve, I'd love to hear it in the comments. That's how I learn and it's how I get my ideas. So until next time, see you, Internet.